Okay, hopefully I can do this in one take. This video is for Gun Sam, revolver aficionado. He's a good gun channel. I like to watch what he does. He's a very good shot. And he also has thoughtful things to say, which I appreciate. Anyway, he had his recent video. He was talking about one of the things came up was the caliber debate. One of those silly debates, 9mm versus 45 ACP came up, and there was a topic on energy versus momentum, and I thought I would try and clarify that as best I can. See, I made notes, but let's make sure I can read the darn notes. Whoops, not the line. I want to make the screen brighter. Okay. And the notes are just basically to save me time because I basically did the arithmetic ahead of time. And I'm just going to explain it. Now, one of the things I did, I'm used to working in the MKS unit systems, Standard International Units. But for this purpose, it's more useful to talk about bullet weight in grains and muzzle velocity in feet per second, rather than talking in kilograms and meters per second. So I had to derive a conversion constant, which essentially allows me to talk with grains and feet per second, because grains are a unit of weight, not mass, and there is a distinct difference. Weight is mass times gravity, and for feet per second, gravity is 32.1739 feet per second squared. That's the acceleration, F equals ma. So, the equations I'm going to use is for the muzzle energy. It's going to be the product of mass, which I'm going to measure in grains, so technically that's a weight, times the square of the velocity, and that gets divided by a constant k, which is equal to 450,435. And don't worry, I'm going to paste this into the information section of the video so you can read it at your leisure. And this is derived from the gravity, the fact that there's 7,000 grains to a pound, and also the 1/2 mv squared for energy, that's included in there as well. So the other formula I'm going to use is for momentum, and I'm going to give it the weird letter P. Don't ask me why, I'm just doing it. It's just a letter. And that's the product of mass and velocity. So m times v. And in order to keep the same value for k, which I didn't really, but whatever, dividing it by, stupid handwriting, k over 2, because this is 1/2 the mass, this is all the mass, so don't worry, this is working out. So, the number that Sam threw out for muzzle energy in foot-pounds for a 9mm loaded, it's actually not that hot. And 45 ACP, which would be on the lighter end, but not by much. There's actually some overlap between 9mm and 45 ACP loads in terms of muzzle energy in foot-pounds. So in terms, if you're debating strictly energy, the fact of the matter is the 45 is only marginally more powerful than a 9mm. That's just the way it is. But anyway, there's also people, of course, who think momentum is very important. And actually it is. If you're knocking down plates, the more momentum you have in your bullet striking the plate, the easier it is to knock the plate down. So that's basically also straight up physics. Anyway, I'm going to let the muzzle energy equal, I'm just going to call it muzzle energy. It's going to be equal to 350 foot-pounds muzzle energy, because that was the number he used in his video. And that's actually quite a reasonable figure. So I'm going to use two different bullets. The 9mm bullet, I'm going to do A. It's going to be a 115 grain bullet, which is a pretty standard bullet weight in 9mm. I personally prefer to shoot 124s. Some people like 147s, and you know, it's up to you. And I'm also going to go with the standard bullet weight for, you know, I'm assuming 115 grain full metal jacket. Doesn't really matter what it's made out of, it's 115 grains. And for the 45, I'm going to go with the standard 230 grain hardball. So, you know, twice as massive. But the energy will be the same. So let's work. This Sharpie is running out of ink on me, and I was hoping it wouldn't do that. But anyway, so for bullet A at 350 foot-pounds, I think for purposes of brevity, I'm going to, since I'm doing the explanation primarily, and I can copy this stuff into the video description, and you can read my arithmetic there more easily probably than my awful handwriting. I'm just going to shortcut the math that I did. A 350 grain, sorry, at 350 foot-pounds muzzle energy, a 115 grain bullet will be clocking out at, let's see where there, I lost it. Oh, there it is. 1,171 feet per second. And that is a pretty typical figure for a 9mm running light bullets. And I think you can even get that out of shorter barrels. That is, I don't think you need a full 4-inch barrel. As for the 45 ACP running 350 foot-pounds of energy, it's going to be coming out somewhat slower. Specifically, it's going to be coming out at 828 feet per second. That's kind of on the low end of 45s. Normally, like for example, a government model, you would be looking, you could be getting into the mid-900s with a 230 grain. So that's where your extra punch is coming from out of a 45. But you can load 9mm hot too, so whatever. But I want to keep the energies equal because what's important is the difference in momentum. So let me sort of push this aside and work out what will the momentum be for the 9mm? Well, that's P equals 115 grains times 1171 feet per second divided by my constant K over 2, which yields 0.5979 pound seconds. And yeah, that's for the, so that's A. Bullet B, the 45. Well, that's going to be a 230 grain, but it's only going at 828 feet per second. And I'm going to divide that by the exact same constant, and we get a different figure, of course. We get 0.8455 pound seconds. Now, what does this mean to a target? It means that the 45 is hitting a little harder. How much harder? Let's put this into a percentage terms. If we do, let's see, how did I do this here? If we go with the increase of momentum from the 230 grainer to the 115 grainer, it would be essentially B minus A over B, which, and to multiply by 100 to turn it into a percent figure, and it comes out to 41.62%. So you got 40% roughly more momentum out of the 45 than you do out of the 9mm at the exact same energy foot-pounds. Now, what does this mean to the shooter? Very simply, more felt recoil. For every action, there's an equal and opposite reaction. So as you sling the slug forward, there's an equal momentum impulse coming back. So if both guns weighed exactly the same, the 45 would be giving you a bit over 40% more recoil. And that might be the difference between manageable and unmanageable for you, or perhaps you're totally recoil insensitive. And it also might mean the difference between knocking over the plate and not knocking over the plate. But, you know, that's minutia. Now, I was going to go and make a prediction based on what work is. Work is equal to force times distance. So if we have this force in pounds and this distance is in feet, guess what? You're getting foot-pounds. That's the same as energy. So if you had the same force retarding each of the bullets, they would both travel an equal distance. So if you're hitting some kind of ballistic medium that somehow manages to have the same resistance to both the 45 and the 9mm, then the bullets would both penetrate the same exact amount into that medium. Now, I was going to say, why not shoot water and see which, make a prediction as to which you penetrate more. And it turns out to be rather complicated. The only rule I know for a moving object through water is Stokes' law. That's fairly complicated. Plus, the bullet's going to be slowing down very rapidly as it moves through the medium. The cross-sectional area of each bullet is different. The 45 has a larger cross-sectional area than the 9mm, which is, a 35 caliber. So it's like 45 versus 35. And So you've got that difference. But the 45 is going slower through the medium. And again, that's a place where velocity kind of dominates. So if all you have is, say, water jugs, and you loaded up a 115 grain 9mm and a 230 grain 9mm to yield 350 foot-pounds of energy, they'd go through probably the same number of water jugs. It might be sitting in, say, the third one or the fourth one. I'm not really sure. Assuming, standard 1-gallon milk jugs. But I don't really know. It's one of those things that's better done empirically rather than doing the math, because the math really does get hairy. I mean, you're jumping up into partial differential equations and such. And Stokes' law is not super simple either. You need to know the molar weight of the water and the viscosity and so on and so forth. And also, Stokes' law is an idealization based on a Newtonian fluid, which means it has actually zero viscosity. It just has the mass. And also, there's no turbulent flow. Believe me, bullets produce turbulent flow when they hit water. So, I hope this is enlightening. I am going to, though, provide an experiment. Sam has a Smith & Wesson 686. Smith & Wesson 686 with a 4-inch barrel. Beautiful 357 Magnum revolver. I'm really jealous. What you can do is a simple experiment. Okay, a common bullet weight is 158 grains in that caliber. So get your tight group or whichever powder you care to use and create a max load for the 158 grain. And then use the exact same powder and primer. And if you have a 110 grain bullets, that's great. But 115 grains, 5 grains, it should work reasonably well. I mean, I'm trying to basically increase the difference of mass as much as possible for this experiment. And basically, load six of these at max charge, and 6 of these at the exact same powder charge. Now, what you do then is fire these 6, whole cylinder. Bang, 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 bang. And then load the 158s and fire those 6. Now, your energy is going to be limited to the amount of powder you have. For example, let's say, hypothetically, you're using, I don't think you're using this much, but let's say you're using a 10 grain powder charge. It's probably a lot less than that, but this is just a number. I don't have my reloading manual ahead of me. So you got 10 grains there and 10 grains down here. The powder has a certain amount of chemical energy in it, which is going to be the top end limit of energy that you put in. So the muzzle energy will be equal to the powder energy, I'll just call that potential energy there for the powder, times efficiency, I'll just call that EF. Now it's possible that the efficiency is going to be quite different between these two bullet weights. I mean, slower powders favor heavier bullets, and faster burning powders favor lighter bullets. And obviously, in all cases, you want to stay within SAMI pressure specifications. So this guy can change on you wildly. But anyway, the general prediction is that the 158 grain bullet is going to produce more felt recoil than the lighter bullet, using the same powder charge. And if you're getting the same percentage energy from the powder charge by some miracle, then your foot-pound energy is going to be the same for the light bullet and the heavy bullet. And the heavy bullet will come out slower, but with more momentum. And the light bullet will come out much faster, but with less momentum. And the heavier bullet will therefore give you more felt recoil than the lighter bullet. So hopefully that it didn't drag on too long. And like I said, I'll post my notes in the description section of the video. And, well, yeah, I guess that should cover it. So, yeah, basically I'm going to be in agreement with Sam on the caliber wars being just silly for the very common self-defense calibers. I personally would carry the 9mm for its size efficiency. It can fit in a smaller, lighter gun with more rounds than a .45 ACP. But on the other hand, you know, you got your revolvers, different animal. Well, it's a lot easier to pocket a J frame than it is an N frame. Or an L frame. I would be, you know, going with 38 Special, which is nice and light, or if I could handle the extra weight, 357 Magnum is available. You know, they're only 5-shot deals, but you do notice the extra weight. Generally, one wants to carry something smaller and lighter. So I would be favoring 9mm over .45 ACP in the semi-autos. I currently am favoring a 5-shot revolver over any semi-auto simply for its just brute reliability. Anyway, that is really now going above and beyond. So, yeah, that was my first. Oh well, yeah. So, end of the video.